Hello, my little triglets. Once again, we are together. It's a happy day. All right, section 7.2. We are going to talk about different shapes of graphs and how to find their solutions and how to draw them if we know their solutions. Some little reminders. Y equals x squared graph is a parabola, and we call it a quadratic function. Y equals x cubed actually kind of looks like the tangent wave, and it's a cubic function. Y equals x to the fourth. It just flattens out a lot more at the bottom, but it looks a lot like the parabola. This is called quartic. And x to the fifth looks like the third, but again, it's flattened out a lot more at the origin. And this is called quintic. I always thought if I had goldfish, two goldfish, I'd name them quartic and quintic. I don't know why. Just thought that would be cool names. All right. Now, at the moment, I need you to give me just a little bit of faith. Because you got to have faith. Faith, faith. Got it? Can you give me a little faith here? All right, I've got x to the fifth minus 5x to the third plus 4x. This is a polynomial. It's a graph. It's to the fifth power. Now here's where the faith comes in. If I were to take this whole equation and factor it, like unfoil it, this is what you would end up with. X minus 2, x minus 1, x plus 1, and x plus 2. So if I foiled all of these together, it would end up being that when all is said and done. So now what I want to do with these parentheses, each parentheses gives you a clue as to where the graph crosses the x-axis. And what you do is you set each of these equal to 0. So x equals 0, x minus 2 equals 0, and solve it. X minus 1, x plus 1, and x plus 2. So solve it. So this is still 0, this would be 2, this is 1, this is negative 1, and this is negative 2. So on the graph, we're going to mark each of those spots. Here's negative 1, negative 2, 0, 1, and 2. So we'll put dots at each one of those, and then the graph itself goes through all of those. Now, I don't know how high or low each wave is, but the general look of the graph will be like that. So if you can get an equation in factored form, you can draw a decent graph of it. Now this has 1, 2, 3, 4 peaks and 4 valleys. Those peaks and valleys we call relative extrema. Now, I don't know about you, but I do have some very extreme relatives. And in this case, there are 4 of them. And if you notice up here, the highest power is 5. The most relative extrema you can have, that's an A, is 1 less than the highest power. That's the most you can have. You can have fewer, but you can't have more than that. 1 less than the highest power. All right, now let's write down some rules for how I knew this arrow was going down, this arrow is going up. All right, so you have your general equation, y equals ax to the n. Okay, first thing, if that exponent is even, 2 things can happen. A can be positive or A can be negative. If A is positive, then both arrows are going to be going up. If A is negative, both arrows going down. Just remember, you have to have a positive attitude, you'll be smiling. Negative attitude, you'll be frowning. If n is odd, you're still going to have two things going on. A is positive or A is negative. If n is odd and A is positive, it's going to look like this. It's going to be rising. If it's negative, it's going to be falling. Okay, so even like 2 and 4, like the hyperbola or parabola, looks like this. If it's odd, like y to the third, it looks more like the tangent wave. So the biggest thing to remember is this last arrow. If it's even and positive, you're going to rise. If it's odd and positive, you're still going to rise. If it's negative, you fall. So positives rise, negatives fall. All right, so let's use that to figure out the equation of this picture. So I've got this, this, and this. We'll say 2, -1. All right, so first thing you do is figure out your zeros and list them. So -1, 0, and 2. Then you put them in the parentheses form. So 0 would be x minus 0. Then we have x plus 1 and x minus 2. Then, most of the time I'll have you leave it like that. If not, I may have you distribute. So these two I'll do first, so x squared plus x. And then I'm going to FOIL that with this. So x squared times x is x to the third. X squared minus 2 is -2x squared. X times x is x squared, and x times -2. Putting like terms together, I have -2x squared and a positive x squared, so that's minus x squared minus 2x. So there's the equation of that graph. Now, if there is a negative in front, then the graph will be the upside down. So if it was normally positive, it would fall. If there's a negative in front, it's going to fall at the end. All right, let's do something called its multiplicities. Multiplicities is where the solution repeats. For example, if I have a quadratic here and it's y equals x squared, I get, if y is, we'll say 4, then x can be 2 or -2. So we have a repeated number sometimes. If y is 4, there's actually 2 answers for that. So we called, when you have more than one answer, multiplicity. And the way you represent that on the graph is if you have a multiplicity of 1, which is just x to the 1 power, it's just going to cross through the graph. If you have a multiplicity of 2, that's like x squared, then it's going to bounce off the graph. Kind of like this one did. See, we go down and then it bounces off and comes back up. If we have a multiplicity of 3, which would be x cubed, it's going to flatten out, then cross through. Okay, we'll do some examples of those. All right, let's say I have y equals x times x minus 1 to the third times x plus 2. All right, so this has a multiplicity of 1. This has a multiplicity of 3, so we just put a little times 3 after it. This is -2. Actually, I forgot the 2 up here. It has a multiplicity of 2. So here we're going to cross through. Here we're going to flatten out a little bit. And then here we're going to bounce off. So we set up our little chart here. Label, here's -2 and here's 1. And let's figure this out. Is it even or odd for the exponents? Basically, if I was to multiply x to the first, x to the third, and x to the second, that would be x to the sixth. So you add up these. If it's not already worked out and you know it's x to the sixth, then you add the exponents. So now I know it's even. So that means either both arrows are going up or both arrows are going down. Well, it's positive in front here, so that means both arrows are going to go up. Now that helps me decide. So I'm going to put 2 dots there to remind myself I have to end up and start at those positions. So, all right, first thing we look at is our -2 because that's where we're going to go first. So I'm going to start here. I'm going to start heading towards -2. Now it says here I have to bounce off of it. So I'm going to go up and bounce. All right, the next one I'm going to hit is 0. So that means I have to go up and then I have to come back down towards 0 and cross through. The next one I'm going to hit is 1. That means I have to kind of come back at it, flatten out a little bit, and then go through, and then end up. So it's still a smiley face, it's just kind of crooked. But because it was even, x to the sixth, then both arrows are going to end up going up. And it's because it's positive, they're up and not down. Okay, now how many relative extrema do we have here? Relative extrema. Well, I know I can't have more than 6, but how many do I have? I have 1 here. Let's try that again. 1 here. Whoops. So 1 here, 1 here, 1 here. I don't have 1 here because it doesn't change direction. This flattens out and keeps going, but so I have 3 relative extrema. And then these would be considered the zeros, they call them, or those are your answers. The x-intercepts, they're named all kinds of things, but the zeros is probably the most popular answer. All right, and when you're talking about the answers, you have to include the multiplicities, otherwise you're going to be missing some of the answers. That means there are 3 answers that are 1s, there are 2 answers that are -2, and only 1 answer is 0, because you have to have 6 answers for that. All right, I believe that is it. All right, I'll see you soon. Ta-ta for now. Oh, I almost forgot. All right, see you later.